What's up, guys? It's still here again after I think it's been 2 to 3 days since I've uploaded my last video, and welcome to welcome to second semester. And I couldn't make a video yesterday and the day before because I was feeling a bit tired, and also because of the reason that on the first day we didn't study anything, but on the second day we did. But I couldn't make a video because I was a little busy and tired as well. But today I'm starting to make a video of the lectures we got today, and we will get from now onwards. So uh, the subject which we are currently studying right now, so the subjects are changed. So nowadays we are studying DLD. That stands for, the abbreviation is logic design digital logic design. And up till now we have been studying, we have been getting the lectures in DLD and OOP, that stands for object oriented programming. So we are also going to discuss what this is. So first of all, let's discuss what is DLD, or digital logic design. So there are two types of formats, or terms, you can say: digital and analog. So digital, as the name suggests, it's about digits, and it can have only two outcomes, or you can say it can have only two digits, that is 0 or 1. So it can have only two states. In digital you can have only two states, that is, you can have either 0 or whatever you want to term it as 0 or 1. But in analog is a continuous state, and also digital is a discrete state, which means it's finite, and it has only two outcomes here. It's also called binary. And analog is a continuous state, and it can have an infinite number of outcomes, or infinite number of you can say states. So the examples of digital can be our digital signals, which we use in our digital or electronic communication devices or computers. For example, in calculators, in cell phones, in memory storing devices, in storage devices, in all kinds of stuff, in digital computers, printers, phones, every kinds of devices which we use in our daily lives. And in analog, we have analog computers, and many other devices which carry out analogous stuff. But in when you have an analog data, and so first what you do is you convert that analog data into digital or tabular form, and then you will be able to process that data inside the computer. Because if you want to process the analog data, you will need an infinite amount of memory to calculate and process the data. That is why you take the digital data instead of analogous data, and that is how you process it. I'm not going to go that deep in these two terminologies because I have many other things to discuss. And what I'm going to start is I'm going to give you guys an introduction about the radix, or different bases introduction on. So basically, digital logic design is all about digits and numbers and digital system. And in digital system, as the name suggests, you have digits, and to know the digits, you have got to know the different bases of the digits. So introduction of the radix, or basis of numbers. So the number system, so there are an infinite system of numbers which we can use in our daily lives, uh, the most common one is your decimal number system, which we use in our daily lives. In our daily lives, we use decimal number system that has a base of 10. That has a base of 10, and decimal number system. It's we have become really used to this system. So, for example, if I say that, as the teacher explained in the class, for example, if I say that 24, so, and if I say what is this, so you will say that this is 24, but this is not actually 24. This is 2 and 4 combined. But we have become so used to this terminology, the decimal number system, that we at once recognize what this is, and we say that this is 24. But instead, what is this? What this is 2 and 4, and and they are added to each other using the decimal number system, that is base 10. You have many other systems. For example, the most common one which we are going to study here is the binary system. So the way the number systems work is, first you have 0. So first you have 0, then you have 1, then you have 2, 3, 4, 5, 6. So I'm writing this list or this sequence for the decimal number system. 7, 7. So I'm going to start from here. 8, 9, and after 9 you have to repeat. You have to reverse this. So this is how every number system works. So after 9, because it's a decimal system, it's up to 10. So after 9, so after, for example, 10 is n, so after n minus 1, you have to reverse the process. So 0, and what you have to do is you have to add, or you have to place the digit after after the first digit in the sequence. So that is 1, and then the 1 will remain the same, and you have to change this. You have to increment the number to the right. So 1 1, 1 2, 1 3, up so on, and after you reach so once you reach 1 9, then you have to put 0 here, and you have to increment. So you start the counting from reverse order again, and you put 2 instead of 1, because you then you increment this one, so this becomes 2, and up to so on. So this is how the decimal system work. But what if I say that there are an infinite number system? So what if I say that how would you write the sequence or the list or the table of numbers that are in base 5, for example, in base 5? So considering the rule and considering the sequence of the decimal number system, we know that once we reach n minus 1, we reverse the process, and then we keep incrementing the number to the most right, and we also put the number or list the number to the left of the number which is being incremented, and that number is the number which is after the first number in the list. So what if I say that how will you write the sequence for base 5? So the way you're going to do that is you're going to do the same thing: 0 1 2 3 4, but once we reach n minus 1, that is 4. After that, we are going to reverse the process, so that will be 0, but we also have to add, or put 1 before it, because that is the rule. Whenever you reach n minus 1, you reverse the process, and then you increment this number by 1, and then you put that number to the left of this number. So that will be 10, 1 1, 1 2, 1 3, and once you reach 1 4, this 4, after you reach n minus 1, so you have to keep in mind, you have to keep track of the number to the right. So once you reach 4, I hope you guys can see this. Alright, so here I'm going to change the page. So once you reach the number 4, what you're going to do is, so for 1 4, so what you're going to do is you're going to put 0 here, and then you're going to increment this number as well. This is going to be 20. Same way, 21, 22, 23, and it's going to go on. So same is the number systems. If I say that what is the number system in base 8, so base 8 would be 1 2 3 4 5 6 7, and after 7, that is n minus 1, you reverse the counting, so you do put 0 and you put 1 before it. This will be 1 2 1 3 up plus 1, and when it will reach 1 7, it will become 0, and this number is also going to be incremented, so 2 1 2 2 and same. But in this is the so we have discussed the base 5, base 10, and base 8. Now let's discuss base 16. So this is called the octal sequence, or octal number system, and this base 16 is known as the hexadecimal system. Hexa means 6 and decimal means 10, so that makes 16. So hexadecimal system, and the way we write it, as you know, the person who introduced it wrote it he or she wrote it like this. So 0 1 2 3 4 5 6 7 8 9, and after 9 in place of 10 we use a. In place of 10, after 9 we start using the English alphabets, English capital alphabets, instead of the numbers themselves. So A B C D E F, so that makes 1 to 9 10 11 12 13 14 15, and the 16th number, so this right here, F, is n minus 1. After n minus 1 you reverse the counting, so this will be 0 and it will be 1. So it will be again 1, it will be 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8, and after 1 9, so this after 9 you put a, remember, so it will be a, like this. So following this sequence, you're going to write the hexadecimal numbers. Now let's discuss the binary number system, and this is probably the most important number system you guys will have to remember, because in binary number system, this is the system which the computer uses to operate and to process all sorts of data. So the computer the computer processor and all of the stuff has only two states, that is either on or off, and it operates on different sorts of voltages and electric currents based on these two states, and that is how your computer operates. And the machine language and or the machine code, you can say, is the binary code. So what is the binary code? Binary means 2, so you can have two outcomes, that is 0 and 1. So that's it. After 1 you're going to repeat the process, that is 0, and you're going to increment this 0 by 1, so that is going to be 1. This one is going to be the same. This is going to be incremented. Now this is 1, this is going to be 0, this is going to be 0, this is going to be 1. Now this, like this, so this 0 became 1. Alright, so now I still get confused in this binary and number system, in binary sequence, when converting or when writing the table of this number system. I still get confused sometimes. So 0 1, and then after 1, alright, so 0 1 0 1. Alright, so this will be 0, and this will be 1, and this will be 1, and then this will be 1, this will be 0, this will be 0, this will be 1, like this. Yeah, so I still it's pretty kind of challenging for me to remember the series, but you guys can follow the same instructions or the same rules as as I stated earlier about the decimal number system. So it all the number systems have the same rules. So after n minus 1, you increment, you first reverse the order, and then you increment the 0 to the left side by 1, and you continue that series up till you reach the number n minus 1 again to the right, and then you repeat the same process over and over again, to the point until you want to stop. So these were some different bases. These were some different bases, or you at the base, or you can say the radix. So these were some different number systems. I wanted you guys to know, to have an idea about what are the number systems, and what are the different radix or base numbers, what are the different number systems. So you have binary, you have octal, you have penta number system, you have, that is 5, you have 10, you have decimal, that is the most common, and then you have hexadecimal, that is also really important. So now conversion between the conversion is probably the most important topic. So the conversion between two number systems, pretty pretty easy, but once you get a hold of it, it's a little complicated at first, but once you get a grasp of it, it won't be as hard as the first time. Uh, so in today's video, let's discuss how do you convert um, let's say, so you have a number system. For example, you have a you have a binary number system, let's say. So you have 1 0 0, and you have this in binary, and you want to convert it into a decimal number system. So what you're going to do, the method for this is you multiply each individual number to the base, so 1 into 2, and you add each product to each individual product of the individual number and the base. So 0 into 2 plus 0 into 2, and while you do that, so for example, this is the point, and this is where the number ends. So starting from this point, you will go to the left, and you will increment the powers of 2 starting from 0. So at this point, the power of 2 is 0. At this point, the power of 2 is 1. At this point, the power of 2 is 2. But these two do not matter, because these two are just going to be 0, so that won't matter. This matters. So 2 into 2, 4, so this is 4, and 1 2 3, so this is 1, this is 2 3 4. So right here, this is 4. This number is 4 in decimal number system, but it is 2 in binary number system. The same way, so you can for example, if I say that what is 10, so what is so the number 10 in base 8, I want to know that what is the number 10, or you don't want to call it 10, you say 1 0, because here this 10 is 8, it's not 10, it's 8, because after 7 this is 8, it's not 10. So I want to know what is this 1 0 in a decimal number system. So I'm going to follow the same process. I'm going to multiply each individual number by the base. So 1 into 8 plus 0, and this won't matter. So and starting from here, so 8, the power of 8 is going to be 0 here, and then 1 here. So 1 into 8 is 8. So this number right here in base 8 is 8. The same way you can do with the base 16. So for example, if I say that what is or you can say can say that what is 8. So up till 9, this is going to be these are going to be the same numbers, but it gets a little complicated once you join the numbers. So for example, if I say that what is 9c or 9d or 9e something in base 10, then you will have to know, then you have got to know the values of these. So this is 10, this is 11, 12 respectively, 13, 14, and f is 15, so respectively. So once you guys remember, so you guys can also make a table for ease, and by looking at the tables you guys will have an idea that how this system works, and what are the equivalent of each numbers, or uh, each individual numbers of and their equivalent uh, and their equivalence in different number systems as well. So a table can be really helpful in this regard. So I had to cover the conversion. So this wasn't it. This is just the conversion from any other number system into decimal. In the next video, I'm going to tell you how do you do the reverse process. How do you convert the numbers which have an integer part and which have a the part after the point, or you can say the decimal part as well. And then I'm going to tell you the arithmetic operations. How do you perform arithmetic operations in different number systems. Introduction to OOP, object oriented program. Okay, I have a lot of stuff left to give the lecture about. So what I'm going to do is I'm going to end the video right here, but I'm going to continue this from tomorrow on a regular basis, and the stuff which got left today, I'm going to cover it on the weekend. So till then, goodbye.